One day after class, Martin and Chenji were ready to have a quick meal.
Wow, why the queue so long, sia?
That's why, wow, if only I wish got more cashiers or more kiosks, wow, then we can faster get our food.
Yeah, sia. Let's go somewhere else. Wow, I'm sweating so badly from the queue just now, sia. So how do we actually solve the long queue problem?
Yeah, I'm really sweating from just now also. I think we really need to find an efficient way to solve that problem. If not, we're going to have to wait very long in the queue. Wow.
Yeah, when can I even get my drink
That's why.
Don't worry, let me show you how to solve it. With our linear regression and hypothesis test codes, we can confidently say bye-bye to the long queues.
Okay, so hi everyone. We are Group 3 and today we'll be sharing with you all our project Optimizing Queue Time for Higher Profit. So this is our table of contents. We'll introduce to you all the introduction to our problem. Then we'll introduce the statistical analysis using hypothesis testing and linear regression. Then we'll tell you all our group's proposed solution and then share with you all our implementation. So let me introduce the background of our problem. So nowadays, fast food restaurants rely on high customer turnover for profitability. Peak hours often lead to long queue times, and long wait negatively impact customer satisfaction, purchase decisions, and store revenue. Now, this leads to our problem statement. Fast food restaurants often face long queue times during peak hours due to an insufficient number of cashiers, leading to customer dissatisfaction and potential loss of sales. Therefore, our project aims to analyze the relationship between the number of cashiers and queue time and recommend increasing the number of cashiers to reduce waiting time and improve store profit. Now, let me pass my time to Yifei to share with you all the statistical analysis.
Hello everyone, my name is Yifei. First, we use linear regression analysis to study how to optimize customer queue time in fast food restaurants. Our goal is to find out which operational factors influence how long customers wait in line. We have one dependent variable, customer queue time, and the three independent variables. They are the number of cashiers, whether it is peak hour, and the average complexity of customer orders. Next, we built a multiple linear regression model. Predicted waiting time includes a base value, effects from cashiers, peak hours, order complexity, and a random error term. This model measures how each factor impacts waiting time. Then, we use RStudio to generate simulated data. We set a fixed random seed for reproducibility and created 50 data sets. Waiting time was calculated using real business logic. Finally, our model is statistically significant, explaining about 63% of waiting time variation. The results show more cashiers will reduce waiting time, while peak hours and higher complexity will increase it. Now, let's pass our time to Annie to explain the t-test.
Okay, thanks, Ife. So next, I will show you a statistical analysis focused on customer waiting time and attrition. Our goal is to test a hypothesis. Do the customers who leave really wait longer than those who stay? To answer this, we set up a formal hypothesis test. The null hypothesis states that non-attrition customers have a mean waiting time equal to or longer than that of attrition customers. The alternative hypothesis claims the opposite. Non-attrition customers actually wait less than those who leave. For the analysis, first I set the random seed to 123. Then generate 50 random values for checkout, peak time, and complexity, and created a group label for customer attrition. After that, I ran a two-sample t-test to compare waiting times between retained and returned customers. So this is the final output result of our code. From the results, it showed an extremely small p-value, far below 0.05. So we reject the null hypothesis. Overall, the conclusion is clear. that longer waiting times are significantly associated with a higher likelihood of customer attrition. Okay, so next I will pass my time to Martin to explain our group proposed solutions.
Thank you, Annie. My name is Martin, and now I explain the interpretation of our hypothesis testing results. First, we set our significance level at 5%, which means we are willing to accept a small chance of error when rejecting the null hypothesis. Next, we look at the p-value from our t-test. In our case, the p-value is approximately 1.377 times 10 to the power of negative 15, which is extremely small. Since this p-value is much smaller than 0.05, we reject the null hypothesis. This tells us that the difference in waiting time between customers who stay and customers who leave is statistically significant. More specifically, it shows that customers who experience longer waiting times are significantly more likely to leave the queue. In other words, queue time has a strong impact on customer attrition. This is important because it provides statistical evidence, rather than just assumptions, that long waiting times negatively affect customers' behavior. Therefore, reducing waiting time is critical. This directly supports our recommendation to increase the number of cashiers, especially during peak hours, in order to reduce queue time, improve customer satisfaction, and ultimately increase store profitability. Now I'll be passing my time to Yufeng to explain our group solution.
Now I'll briefly move to our solution. Based on our analysis, we recommended adding more cashier during peak hours to reduce waiting time and improve customer experience. The linear regression outcome indicates a statistically significant negative association between the number of cashier and queue time, which implies that hiring more cashier can effectively reduce waiting time. Also, we utilize a t-test to determine if long waiting periods cause customers to abandon the restaurant. In accordance with the central limit theorem, the test is valid, and it is apparent that individuals leaving the restaurant have experienced a considerable wait period. It is vital to cut down queue time, since it enhances customer satisfaction and decreases attrition.
Okay, let us see what has happened to the renovated restaurant. Wow, the number of cashiers has increased, and the queues are shorter too.
Now we are so happy with our food, man. The food came so fast after our solution.